So, hi everyone. I hope all of you are good. And we'll start with the recap of the last session. Okay. We covered these topics in the last session. So, any of you have any question, or whoever joined for the first time, if you have any questions related to any of these points, do let me know. I would try and answer those questions. So, these are the four main pillars of OOPS: abstraction, encapsulation, inheritance, and polymorphism. So anyone who wants me to recap any one of these points with an example or anything, do let. So abstraction, as I said, abstraction and encapsulation are not two different points. These are the same point with a different perspective. So these are the two main points, okay, of OOPS. Abstraction means, looking for the data which is relevant to you, okay, extracting the data which is relevant to you. Encapsulation is hiding the data which is irrelevant. So you can, whereas inheritance is a concept of parent and child. Of inheritance, base class and child class. Anything which is common would go in base class. Anything that is specific would go in child class. Abstraction, we have covered. Encapsulation, we have covered. Inheritance, we have covered. Polymorphism is a concept where the same function or the same person behaves differently in different situations, different behaviors for different inputs. That's a concept. So these are the four main concepts: abstraction, encapsulation, inheritance, and polymorphism. Now, in interview, this is the basic question that will be asked. What are the four main pillars of OOPS? So the four main pillars of OOPS are inheritance, abstraction, encapsulation, and polymorphism. Okay, so these are just the concepts. Then the second question would be, how do you implement these concepts, let's say in Java? That we are going to see next. Any question till now? So accessing something which is public is abstraction. Hiding something which is not relevant to the end user is encapsulation.
Okay. I think abstract keyword we can use for methods only.
This is very good question and very common mistake. Abstraction has nothing to do with abstract class. Okay, if you say we can implement abstraction through abstract class, it is partially correct, not 100%. So we'll start with the point. Very important and very critical point: data. Now, what is data? There is a slight difference and very minute difference between data and information. I'll tell you what is the difference. Difference is data can be anything that you see. Okay, you watch a news, that is data to you. You're taking an input from a news. You used to watch, I'm not sure how many of you, but I used to hear news on radio as well. So that is audio format of data for me. News nowadays is a video and audio format for me. Okay, so audio video is a data. Okay, newspaper text format is a data. Okay, nowadays there are meme concept. Okay, people are creating memes all across the thing, right? Memes are nothing but images mostly. So images is also a data for me. So images is a data, audio video is a data, video itself is a data, audio itself is a data. Everything around you is data. But what is the difference between data and information? Information is a thing which is relevant to you. Data is anything around the world. This is generic. This is specific to you. If it is relevant to you, it is information. If it is not relevant to you, it is just any other data. Okay? When you break audio, video, and guys, if you can mute yourself. Uh, okay. So when you break audio, video, and images, there are three primary type of data. One is integer. Okay. Other is character, and the last one is float. Okay, so integer, character, and float are the three primary data which cannot be further divided into any smaller part. So integer is the smallest part, character is the smallest part, and float is the smallest part. Meaning you can combine these three type of data and create any type of data in the world, be it audio, be it video, be it image. So these three are called as primitive data types, primary data types. Okay, so these are primitive data types. Any question? Integer, character, float. Three basic type of data or data type. So now obviously these are three different type of data, right? So they cannot fit into a same room. Similarly, int might need X amount of space. Character might need Y amount of space, and float might need a Z amount of space. Now, what is this space we are talking about? These are all data. Okay. Now, when we jump into programming, all data are stored in something called as RAM. Okay. RAM is a random access memory. So in this memory, you might have heard I have 16 GB of RAM. RAM is a random access memory. Anything that you create is stored here temporarily. For permanent, it is stored in SSD or something like that. But we are not going to go there. We are sticking to this point. Okay. So anything that we are going to create would be stored in RAM. So RAM is a storage location. Okay. So any type of data that you will be creating would be storing in RAM. So let's say if it is of 16 GB, then int might require 4 byte, char might require 1 byte, and float might require 8 byte. That's the reason why they need different space size in your RAM. Is it clear? Okay. So each type of data has its own size. Okay. So integer might require 4 byte, character might require 1 byte, and float might require 8 byte. Why I am saying might is because this depend on the programming language and the compiler. Okay, C# has its own size standards. Java has its own size standards. So for now, let's go by a generic. Integer might require 4, character might require 1, and float might require 8. So now what we have learned, there is something called as data. There are something called as data types. So there are three basic data types. So we are going to start with basic, then we will jump into complex. So what are the data types? Integer, character, float. They have their own size in the design. Okay. Now, so we have learned data and data types. Now let's see how to tell a compiler that I want to reserve a space in your RAM. This is your RAM. I want to reserve a space. So let's say I want to reserve this space in my RAM. So what all I need to tell? I need to tell how much space. Okay, how much space? What would be the nickname of the space? And what value are you going to store? Correct? These are the basic things. How much size do you want? What name would you call it by? And what is the value that you want to store? Right? This is exactly how we declare a variable. Okay. So let's say I want to call my variable as A, but I need to tell the size. Size depend upon the type of data. Right? We just saw, right? Integer require 4 byte. So this means size. This means name. And this means value.
Value.
How, name, and value. This is the exact definition of creating a variable with a value. So this is data type. This is name, and this is value. Simple.
Yes.
Data type, name of the variable, and value. Let's take a look at other data type, right? So what we have learned, integer, character, and float. अभी अपने को इतना ही पता है, right? We only know integer, character, and float. So we just saw how to create an integer array. How it is int, let's say I equals to 10. Okay. Similarly, character would be char t equals to. Now this right here is a universal rule. This is not related to Java, not related to C Sharp. This is a universal rule that characters should be always in single quote. Okay. And then float would be, let's say, f1.1. Now you see the difference, right? Why I cannot store float like a int? Because int precision does not include decimal values. Int we cannot store any decimal values. That is the reason why float is a different data type, because it has a precision of storing the values to the decimal places as well. Okay, that is the reason why we have three basic data types. One is int, other is char, and third is float. And this is how you create the variables and assign the values. So till this point, this is called as declaration. I'm just declaring to my compiler that please create a variable space empty of this size. But when I say equals to value, this is initialization as well. This is declaration and this is initialization. Now there are certain operations that can be performed on data types. What are those operations? Plus, minus, multiply, and divide. And there is something called as modulus in programming. Okay. So plus is the operator. Okay. All of these are operators are like this: 2 plus 2. So this 2 and this 2 are called as operands. इनको प्यार से operands बुलाया जाता है, प्यार से नहीं, इनको operands ही बुलाया जाता है. These are called as operands. Okay, this right here is called as operator. Operator operates on operands. Is this clear? So this is an operator, minus is an operator, multiply is an operator, divide is an operator, modulus is an operator. Now I think plus, minus, multiply is straight, but if you have any questions, you can ask. What I want to focus is on divide and modulus. So what is the difference between divide and modulus is that, let's say 5. So 5, I want to divide 10 with 5. So when I say 2 times 5, it is 10. So this particular thing is called as remainder. Okay, and this is quotient. So when you say divide, you get this value. When you say modulus, you get this value. Okay, so this is modulus. When you do modulus, you get a remainder. When you do divide, you get a quotient. Any question? You understood the concept of variable already. Okay, but let me just brief you again what is variable technically. So technically it is called as name, storage, location. Just three words: name, storage, location. Variable is something which has name. Variable is something that stores. Variable is something that has a location as well. Now, concept. Animal is a concept. Human is also a concept. But what is actual is me standing here. I am a actual physical existence of human, right? Similarly, Saurabh is actual physical existence of human. Saurabh इंसान नहीं है, सौरभ इंसान जैसा है, ठीक है. He is like a human. He is not a definition of human. He is a type of human. I am also a type of human. All of you are human.
Means human is a class.
Correct. So human is a concept. We are the object.
Objects.
Okay. So this is a concept. This is a physical object, physical existence. Now take a look at human in a little depth. Okay. So now if I have to define a human, how will I define? I will say, you know what, it will have a height. Okay. And it will have two nose, 2 ears. Sorry, not two nose. One nose, 2 ears, 2 eyes. You can correct me where I go wrong. Okay. So this is certain things, certain attributes. But this defines the UI of human, or you can say how it looks. But there is other aspect of human, which is behavior. So these are the things which defines how it will look. But there are certain things which defines how it will behave. So he can walk is a behavior. He can run is a behavior. He can eat is a behavior. He can help, which we all forgot, is a behavior, right? So help is an important behavior. So these are behaviors. Now we all know how we can store height. We just learned, right? Variables. Variable is something where I can store height value. I can store height value as variable. I can store ear value as, no, this was nose. Okay, this was ear. And this was, I forgot, let's say hands. Okay, so I can store height in a variable, nose in a variable, ear in a variable. Let's say complexion of a person also in a variable, brown, white, black, whatever, right? So this can also be a variable. But these are the common attributes of all humans. This is behavior. Okay. Now, how to handle this in class and objects? So I know class, I can create these variables, my class is done. What about behavior? So behavior can be handled through something called as function. Okay. So we call it as function, we can call it as method sometimes. Okay. So methods are the ones which define the behavior. So behavior is one attribute, and usually these other things are called as attributes. Okay, like my height, my complexion, my width. Okay, all of these are attributes. Behavior is a function or a method. Function or a method. Method we usually call in C sharp. Function we usually call in Java. Different name, same concept. Got the point? So object or a class has these two important things: variables and functions. This is variable, this is function. Only two things: variables and functions. Let's say I have a class human. Okay, I'm not going to write all of them. I have a hand. Let's keep it simple, hand only, nothing else. Okay. Now I created two objects. One is Praveen and one is Suraj. Suraj just asked the question. Okay. So Klaus has a hand and it can cook with the hand. Cook with the hand, nothing else. Only cook with the hands. Okay. So I can also cook with my hand, and Suraj can also cook with his hands. One fine day I was traveling. I met a accident. I lost my hands. Will Suraj lose his hand? But there is something that goes with object, and that is variable. Only the variables are replicated for each object. This is the object. It has its own copy of variable, and this has its own copy of variable. Meaning, if my hand will not work, it has nothing to do with what Suraj hands can do or cannot do. Got the point?
Yes.
Okay. So every object has its own copy of variables, has its own copy of variables. So eyes, again, another example. If my eyes will not work one day, Suraj's eyes will remain as it is. Because I have my own copy of eyes and Suraj has its own copy of eyes. So object basically has its own copy of variables. Every object has its own copy of variables. So if the copy of variable of one object changes, it will not impact the copy of the variables of other object. Is that clear? Let's say employee. Okay. Now employee has a salary. Guys, mute yourself. Okay, employee has a salary, and salary is a variable. Now Praveen has a very low salary. Let's say 10K. But Suraj ने message लिखा. Okay. So Suraj has 50K salary. Clear, right? Employee is same, variable is same, but Praveen's salary is different. Suraj's salary is different. Simple.
Yes.
It's the same variable, but having different value, which has no relation with the same variable of the other object. So this is object, same variable storing 10K, same variable storing 50K. Last example. Okay? Done? Okay.
Done.
Let me ask you a question now. Okay. Now, salary hai, so there would be a tax also. Okay. Now, let's say I have three objects: employee 1, employee 2, employee 3. Okay. Now, when I say every object has its own copy of variables, now I have two variables, salary and tax. So this will have salary, this will have tax. This will also have salary and tax. Salary and tax. Now let's assume for a minute that tax is common for all employees across the globe. Okay. So that means this stores 10% of tax, 10% of tax, and 10% of tax. Now tomorrow there is a new rule passed and the tax percent is changed from 10 to 11. Now will it only impact employee 1?
No, it's applicable to all.
It's applicable to all. As I said in the beginning, right? It is applicable to all. So this will be 11, this will be 11. Now, do you see any problem in this code or in this theory or in this concept? Anyone? Any problem?
Yes.
What is the problem?
If supposing we have about 1,000 employees, we have to change the percentage, and that will be a kind of work. So I think we can get a generic maybe a data for that. That will, when we make a change, it will affect all the employees.
Perfect. So what he said is, if I have 1,000 employees and I see the value of the tax is same, going against the basic definition of variable. Why variable was created is to store the value of objects so that it should not impact the different object variable values. So this is 10K, it should not be affected by 50K, it should not be affected by 60K. That was the basic concept of variable. Why variable was created? It's a variable, it can change based on the objects. But this is violating that thing right at the top. Okay, this at any given moment of time is same for all the objects. If it is 11 for this guy, it is 11 for this guy also. This guy also.
Yes,
So
yes.
same. Let's go back to the space. What I told you, integer takes 4 bytes. 1,000 employees, 4,000 bytes to store same value. What is the use? I am wasting my 4,000 bytes just to store a same bloody value. Does that make sense? No, right? That is where the concept of static comes into the picture. Static says, I will be the one which will be a variable. It is not a constant. Don't ever go and tell in any interview that static is a constant. It is not at all a constant. You can change the variable value, which is of static, any given moment of time. So this is not a constant, but it is a variable, but it is a special type of variable which sits on the class level. It sits on the class level, meaning it will have only one instance
Instance.
for the entire class. For the entire class, meaning tomorrow if this employee goes from 1,000 to 2,000 does not matter. It will have only one copy of tax. So instead of wasting 4,000 bytes, I'll be having only 4 bytes to store my tax. How much byte I saved? 3,996 if I'm correct. Right? A lot of memory.
Praveen,
Yes.
I want to question on mine.
Yes.
Static we can only use for only text purpose, right?
No, it's not like that. You can create static for anything. So
No,
now,
no, in that example.
in this example,
Yes.
we are storing a number, right?
Suppose 2,000 employee are there and same tax applicable for all that 2,000 employee. In that case, we can declare this variable as a static for tax only, right?
Correct. So instead of saying this as int tax, now I can say static int
Yes.
tax. Okay, let me. So this is tax. Tax was a variable. So if I have to create a variable, I say declare a variable. I'm declaring a variable like this. But if I have to make it static, I just have to say okay. That's it. Now, instead of sitting on an object level, now it will sit on a class level. So for the entire class, this will be only one copy. So session is about to end. One tricky question. Okay, now this is employee. There are 2000 employees. Okay, now if the value of tax changes from 10 to 11, will it change for each object?
No.
No.
So if I try to get the value of tax now, what will be the value? What
11
will
for
be the
all.
value?
For all employees, 2000. It will be 11 only. Same.
Perfect. So for everyone, it is 11. One copy shared across the objects, saving the memory. That was the reason why static was
Introduced. Yes.
introduced. It is not a constant. Never say that in any interview. Static
Final is constant. Final is constant.
perfect. Final is constant. So just quickly